Hello everyone, good morning. Today I'm going to discuss on Azure Data and Analytics. As we have seen that most of the sessions on AI, on all the Azure services, but in order to go on AI part, we should be knowing how data is consumed, how it is transformed in order to work on any of the AI platform. Here I'll be exploring few services on Azure Data and how we will be going ahead with the analytics part. Okay. Now, let's start on the points or the topics that I'm gonna cover in Azure Data and Analytics part. Is first is data ingestion, second is data storage, data processing, analytics, and Power BI. What is data ingestion basically? Data ingestion when we are getting data from multiple data sources, like it can be SQL, it can be file storage, it can be any NoSQL, SQL database, or it is a event-driven real-time database. So we need to know how we have to get that data, transform it, and then process it accordingly. So for that, we will be using different type of Azure services like Azure Data Factory, Azure Event Hub to get the real-time data. For data storage, so once we get that data for data storage, we know what are the different types of services, that is AD, Data Lake, SQL database, as well as Cosmos DB. Data Lake can be used for storing file systems, SQL for structured data, and Cosmos is for no structured database. And once that data is stored, we can use that for processing using Synapse Analytics, Databricks. I'll go in all this services in detail over the next slides. I'm just giving a highlighting over what we are going to cover on the data processing part, data storage part, and in analytics, Power BI, and Azure Machine Learning. Now, coming to data ingestion, what are the different types of data ingestion we do have while working on any of the application? It can be a batch data ingestion where we are reading the data from time to time. Let's say I have millions of records and I will be getting that data into a chunk of 10,000, so that it will help in improving my performance of the application. So that will be a batch. Second one is streaming data. Let's say I have to get sensor data, and that sensor data needs to be real time based, so that I can get logs, I can work on any of the automation, I can give forecast on that streaming data. So the streaming is one type of data ingestion. Micro batch is one thing where we can divide that data into seconds, into minutes, and we will be using APIs to pull that data and provide telemetry and forecast. CDC is near real-time data where Azure Data Factory has been used, Synapse we can use, and the best use case is the syncing of database. If we go ahead with the on-premise system, we will be using SSIS service. If we are going with Azure services, we will be using ADF Synapse to pull that data, write the store procedures, and put it into database. So that is a weekly or scheduled jobs that we can see. File-based ingestion is normally when we put all the CSV files on any of the storage system, we are connecting to that storage system and scheduling it and putting it into data storage, Azure Data Storage, blob storage, to read it, transform it, and feed it to any other third-party services. So all these are the different ingestion types where I'm gonna cover batch and streaming in detail. So first is batch ingestion. As I have already mentioned, where we have multiple data sources, like it can be a file system, SAP, SQL Server, and Oracle. Let's say I wanted to have accounting related data from SAP source system, or any HR related data from SQL Server. So I'll be connecting all these databases to my ADF, and ADF will be connecting to this database, pulling that data and putting it into Azure Blob Storage. So what it generally does is, in ADF, I'll connect to that data, fetches the data, create a CSV file, and put on the storage file. Here, I'll also use Python scripting, where Python script will work on its transformation part, fetch that data if any transformations needed to convert some of the data, then that is done through Python script, and that file is getting stored into Azure Blob Storage. Now that we have all the transformed data and processed data, we can pass it to Azure Synapse for analytics purpose. So it is called as batch ingestion, where I am dividing that data into chunks using Python and then putting it into storage. Looking into real-time ingestion, where many organizations or many industry is looking into, where we want IoT sensors data needs to be captured on real-time basis. Apart from that, some textile industry wanted to work on the color coding checks. So this is all weather forecasting data, temperatures forecasting data. All this data can be captured through real-time ingestion, where we are capturing data through sensors. And if we are not having sensors installed, then Azure Digital Twin comes in picture, wherein that picks up data into uh, simulated format and passes it into log file or any CSV file. Some of the real-time ingestion can be captured through binary file system, and some of the data ingestion can be captured through cloud services. So all this data can be captured and passed it into Event Hub. So Azure services like Event Hub, Blob Storage, and IoT Hub can be used to integrate with the sensors and work accordingly for transformation and pass it to Stream Analytics for analyzing and processing it. So here, once we are done with capturing that data through Event Hub processes it and pass it to Stream Analytics, where Stream Analytics gets the reference data, let's say weather related data. So if I wanted to forecast on weather related data, so reference data needs to be used that to check what is the reference range. It can be a seed data, and Azure machine learning can be integrated on top of it. As we have checked what are the different ingestion what are the different data ingestion, we also need to know what are the different storage patterns inside Azure, and how we are gonna use it and for which purpose it will be helpful. First is ETL and ELT. Why, when it is needed, why we have to select it depending on cost. So all that comparison I have mentioned it. ETL is needed for medium storage, like data volume is into millions of records, but ELT is required if we are going with the high data set. And as we all know, the data structure changes from time to time. If we are going with IoT sensor data or any real-time data, then the semi-structured or unstructured data is mostly used. In this real-time world, like going ahead with the AI technology or any chatbots, then we mostly prefer with ELT pattern, that is semi-structured data. And if we have to go with HR data, accounting data, a structured kind of data, then we can go ahead with ELT pattern. Processing engine. Now, the processing engine used or Azure services used for ELT is Azure Data Factory, and for ETL pattern, Azure Databricks, and Synapse serverless. The transformation used inside the ETL pattern is outside. So let's say I am using Azure Data Factory. Now outside storage is like I am using Azure function in order to transform that data, and storage for storing it, all the transformed data set. But ELT pattern works on transformation as well as storing on same Azure service like Azure Databricks. That's why it is mentioned as inside storage. And storage type, which I have already mentioned covered, is blob storage, Azure SQL, and Synapse SQL. So that is for ETL pattern, and for ELT, it's Databricks, ADLS, Delta Lake, and Gen 2 storage pattern. Now, for curated, the best practices for ETL is enterprise workloads that I can see. And if we are looking for flexibility, scalability perspective, then we should go with ELT pattern. So this is the architecture diagram where, or block diagram, where we can see how ETL and ELT works. Basic, the in ETL pattern there are two variants, that is basic variant as well as common variant. We are just looking at source, transform, and target, that is extract, transform, and load. That's what is the basic variant, where Azure Data Factory comes in picture, which helps in extracting data. Azure function comes in picture, which works on transformation, and storage comes in picture, which will store the data into our target repository. And generally common variant is like, as we are working for enterprise application, we do have multiple environments. So for that we are having dev, stage, and production. So in this common variant, when we extract the data, we put it into stage environment or dev environment, and on that environment we work on transformation and loading. And once we done with checking of the all the data set, we will be transforming it into target, that is production environment. Now coming to ELT, like here we are fetching all the data from here. Also we can use ADF, but I would suggest if we are using ADF, then putting that data into Databricks for any transformation or any analytics purpose. So staging tables are needed. First here we will be loading that data. So ADF will be used to load that data and put it on Azure Databricks, and then we will work on transformation part. So that's where, when we have large data set, this will be helpful. I guess most of the people are aware of ETL and ELT, but there are three more data patterns where we are having extract, load, transform, load, where we can bring in data warehouse and data lake in picture. And for that, Databricks is the Azure Databricks is the service which we can use to load and then transform and then load. So as name suggests, source, we will be using Azure Data Factory to extract it and then putting it into Azure Databricks. And then we will be loading that data into different types of databases, like raw database, curated. So there are different types of layers in that data lake, where we will be storing original data set. And once done with the transformation, then we will be having our curated database. And after that, completion of transformation, we will be storing that into a detailed warehouse, where we can say it is a production ready data. Now, as I have mentioned, there are three data patterns, like here also extract, load, transform, load, and transform. So what does generally says? We generally do that in our data hygiene practice, but we don't know what to call it. Like we extract the data, load it, then clean that data, and then proceed it for transformation purpose. So that's what we call as extract, load, transform, load, transform. Here we are cleaning, as diagram suggests. Once we load that data into data lake, we are cleaning it, then transforming it and loading it to data warehouse product for production purpose. And this is the data lake house for ELT. First extract and load, and then transform for and push it into production for reporting. So here we are dividing that data set into multiple data set so that it can be used for analytics and any machine learning services. Now, as I have covered storage patterns and data ingestion, we will move ahead with the analytics and its Azure services. Azure Synapse Analytics. So there are two services which I am going to highlight is Azure Synapse Analytics and Azure Databricks. When we have to use it and for what use case, and what is the cost implication on both of that. So when we have to go ahead with analytics of SQL or any structured data set, then the best way to go ahead with Synapse Analytics, where dedicated server is available and we can have a big data or ML on top of Azure Synapse. But we can also say, you can also see that big data can be possible on Azure Databricks. Then what is the difference between both of them? Main differences like structured data, and Azure Databricks helps with unstructured data set, which will help in analyzing our forecasting data. Here, Azure Synapse Analytics can be integrated with Data Lake, Power BI, and ADF. So, if I don't want to use Azure Synapse internal factory to get that data, I can use Azure Data Factory to fetch that data and put it into Azure Synapse, and then work on its analysis, and then connect it into Power BI to give the reporting to as a reporting tool. So the main use case for it is enterprise data warehousing. Like I have done one application on Azure Synapse Analytics for manufacturing related data, where I am using accounting data to store to work on its analysis, transformation, and creating reports on that accounts. Now, real-time analytics can be possible with Synapse Link, but as we say that Azure Synapse is little bit costly if we are looking for big data. Here, Azure Databricks comes in picture, which will help in transformation of big data. It will give us storage, as well as it gives us an optimized engine to work on machine learning space. So here we have Delta Lake for storing all the different types of curated data, and it also gives us a space where I can write Python. I can use different technologies like Python, Scala, and SQL. That doesn't have case with Azure Synapse. Like we can only use T-SQL queries to go ahead and work. It will also gives us notebooks, and we can also auto scale those clusters for if we have to work on its if we have to look for its major workloads. Advanced analytics can be possible. Here we can also go ahead with stream and batch processing, and IoT and anomaly detection is possible through Azure Databricks. Now, Azure, there's one more analytics what is Azure Stream Analytics? Why it is being used? So, as the name suggests, real-time stream processing engine is for processing our real-time data, IoT data. This Azure Stream Analytics is majorly used. So, but here it doesn't give us access exposure to work on Python or any other technologies. Here we just need to work with SQL and event hubs. It integrates with event hubs to capture all the data, real-time data, and pass it up accordingly for analytics, where we can go ahead and look into alerts and monitoring if there are any failures happening on the sensors. That will also send a notification to all the users if we configure it. So main use case is telemetry and log processing. Now, how will you decide based on scenario that which one should be good, or when we should select that? If we are looking for large data sets, BI and SQL related data set, then Synapse Analytics is the best. If we are going with real-time data for sensors and logs, then Stream Analytics is best. But if we have to go ahead with modeling and experimentation on any of the forecasting data, then Azure Databricks and AML is the best suitable service. And for unified lake and data warehouse, Synapse with serverless SQL. After this part, in this overall flow, AI and machine learning comes as a third part when we fetch that data, transform it, store it somewhere, and then this comes in picture like how we should use that data which we have stored till now. There are different services which are available on Azure. Azure Machine Learning is one of them, and cognitive services is second. So first we will go with Azure Machine Learning, where what are the different forecasting things, or what are the different models that can be used, how we can train it, what are the different types of data, is complexity of data is possible through Azure Machine Learning. So these are all the details. I'll highlight it. What are firstly going with the features on Azure Machine Learning, where SDK based pipelines can be integrated with Azure Machine Learning. It helps in monitoring of the models, and automatic scaling of the models is possible through Azure Machine Learning, and its integration with Synapse and Databricks is possible. Now, here, which industry or what are the different use cases should be considering Azure Machine Learning? When you have to customize your own data, when we have to use our complex data science models like deep learning, time series model, if we have to train any data on large data set, then this ML ops, it will help in giving us the ML ops best practices. And if we are looking for proprietary AI algorithm, because if we are working on any open source, then there are various challenges that we may face on proprietary licensing requirement. So this will help us giving the proprietary and giving us more flexibility and feasibility to work on all the latest models. Now, coming to Azure Cognitive Services. Here I can give my own experience in Azure Cognitive Services, where I have used this to capture data from any of the image and map it. Let's say I have used Azure Cognitive Services and uploaded my flow diagram. Now, Azure Cognitive Services is reading that data set, fetching data from all the each and every model and connecting that models, giving me proper response. So, as we have seen in this example, that we are first transforming that data, fetching that data, ingesting it, transforming it, and processing it for Azure Machine Learning. So here If I give this diagram to Azure Cognitive Services, it will give me the exact details, what is written in that image and how it is being connected. So my your experience over here it has is it has pre-trained models where we can directly integrate it into our data science application where we need some expertise. We don't have to go from scratch. So where image analysis, facial recognition can be done through cognitive services, and translation, sentiment analysis is possible. Apart from that, speech to text, voice recognition is possible through cognitive services. It has ready to use AI features. So, and that's what I have used in reading the flow diagram, connecting it, and then pushing it into Neo4j for getting all the detailed analysis. As while going through different services, I have already mentioned few of the differences, but again, in order to highlight why it is being used, when it is being used, I have created a different a tabular format differentiator with respect to different features like purpose, user profile, where the purpose of Azure machine learning is build, train, and deploy custom models. But as we have all seen, the cognitive services can be used for using pre-trained models that can be used for building this for using profile. I have just highlighted data scientist and ML models, but this can be used for non-ML specialist as well, which they can, by knowing the name of the model, they can directly use it in their application by connecting it to APIs. Full control over algorithm where we can go and customize it. Here we need to work on its plug and play where some training is needed. We have to do some trial and error on this. And language supported is Python, R, it's low code, no code. And in Azure Cognitive Services APIs, here we can also integrate with the REST APIs. Here, through REST APIs, I mean, we can also use Lambda, we can also use Python, SDKs, JavaScript, Node.js. So we can use any technology to connect with this through APIs. Different types of integrations can be done through machine learning as Azure Synapse, Databricks. AKS is for if you want to deploy any model, then AKS can be used, and pipelines can be integrated for data ingestion and data fetching. Now, going ahead with cognitive services, if we get that data integrated through APIs, we can directly use that cognitive services inside our apps, in our Power Platforms, or in our chatbots. As I have already highlighted, use case, predictive modeling, forecasting, or any custom NLP custom data sets. Here in Azure Cognitive Services, image recognition, sentiment analysis, facial recognition can be used in cognitive services. Infrastructure, here we can configure our own compute. It's custom. We can scale those services. We can configure it. But cognitive services, we don't have that control. It is managed by Microsoft. And from scalability point of view, we can scale, orchestrate. Here, scalability can be done if, as and when we are using API endpoints. So support, which was given by ML, yes, through CI/CD models, through model versioning. Here, support is not required because it is totally managed by Microsoft. Now, moving ahead with visualization and business insights. Uh, there are different types or tools that we can use on Azure. That first is Power BI with Microsoft flagship BI tool, wherein we can connect it with to Azure data sources like SQL, Synapse, Data Lake, and Cosmos DB and get our real-time dashboards. Even we can connect it with Stream Analytics or Event Hubs to get real-time data, and it has all the level of filters wherein any business analyst can go and use Power BI to go for reporting purpose and go ahead in front of customer for any kind of demo. So if they wanted to have any KPIs for executive level, they can use this Power BI tool to generate any reports, because it doesn't need to have that expertise of any language. It just applying or any filters or any KPIs on that dashboard to use it. If another different type of use case is creating sales performance or forecasting any details, any operational efficiency reports that we have to create, that can be done through Power BI. That we have seen that Power BI plus Microsoft tool and SQL tool. Here, I'll be just highlighting you on Azure Synapse and Power BI integration, which is possible with Synapse SQL pools for live analytics, which can be used for forecasting related data, temperature analysis, weather. So Synapse plus Power BI will be helpful on real-time analysis, where we have centralized data lake analytics and visualization. In order to get that real-time insights, what are the different types of tools involved and where it can be used? Azure Stream Analytics, Power BI Streaming Database, and Event Hubs or IoT Hub can be used from Azure. And different types of use case like IoT for health monitoring, website, traffic dashboard, fraud detection in any financial systems can be uh, done or used on these tools. Advanced analytics with AI. This can be possible with usage of Azure machine learning and putting it into any SQL server or any data set, which then can Power BI can connect to that databases or tools for giving us advanced insights, which will help in explainable which will help in creating reports which can be explained to all the users, to business, and it can give us predictive dashboard without coding, and any AI insights which BI user directly can use it. Now, what are the different tools to enable business insights? Power BI, what's its tool? Visual dashboard with interactive reports. Azure Synapse Analytics is one of them, where we can have this insights on unified data warehousing and advanced analytics. Azure Machine Learning for predictive insights and forecasting. Data Factory, data integration and multiple data sources. And Data Lake Storage is for structured and unstructured data analysis. So that's all from all different types of services, where we have covered from ingestion to analytics. Now, time for demo. Let me just pull that up. Okay. I have recorded this demo so that we have time. Okay. Here, what I have created in this pipeline is fetching data from IoT sensors, where I am using Azure services like IoT Hub, then Stream Analytics, putting it into Event Hub, and then Event Hub will be storing all that data into storage. So this overall demo shows real-time IoT data pipeline using Azure services. Just to go through it. Your Azure services IoT Hub can be used for receiving data from IoT devices. Python script for sending temperature data to IoT Hub, that we have written it into Visual Studio Code. And just a second, let me just go back, pause here a bit. Stream Analytics is being used to connect IoT Hub to Event Hub using SQL queries. Here, for storage account, blob storage has been used to store temperature related data, and containers inside that blob storage. We have created containers, and function has been used to trigger the Event Hub message. Now, moving ahead to all the services and how we have created. So, here I have created all the services using IoT Hub. Now, inventory tracking has been used over here to create my to fetch my sensor related data and then pass it on Event Hub. Let me just go. So inside this inventory tracking devices, where we can create new, click on plus icon and create that device. This device have all device ID, primary key, secondary key, connection string, and primary connection string and secondary. So we can use that primary connection string and integrate in our application to fetch all the real-time data through event hubs and then pass it into our data set for analytics, where I have created temperature namespace and different location. Just go through. Now, once connecting using that device ID and primary security key, temperature related data has been fetched from sensors, which I have already created on device sensor. And that data we are used for streaming. This is the upstream analytics job, which I have already created. If you click on that stream analytics job, so we will be we will be getting all the data which we are fetching it from sensors using SQL statement, which I have already mentioned in our previous slides, that we can only write SQL in stream analytics to fetch that data from sensors. And this is the simulated device. Here I have written code it into Python to fetch that data from sensor and pass it into our stream analytics. Once we run the simulated device, it sends message, temperature related data, real time data to our IoT device. IoT device will go ahead and capture that data and then process it and store it in our logs, that is temperature logs. And so currently, I have shown all the logs which are not is not having data. Once we start our process, let me just show. Here, I have written Azure function in order to fetch the data which has been transferred from Python device and then pass it into our uh, event hub. These are all the different types of settings which I have done on Azure function. Once done with that, I'll just run through Azure function. Event data has been received. The data which I am passing it through Python script, it has been received from Azure function, and we are storing that data into Azure storage, where on the way I have already mentioned that earlier temperature logs which are blank, now temperature logs has been captured. We can go ahead and check all the data by downloading all the JSON files which are present on blob storage. So if you see here, data which I have transferred from Python script is being captured through Event Hub and stored it into our blob storage. So that's it from demo point of view. If you have any questions, You can ask.
All right. So